Rewriting oxytocin's love story using CRISPR. Rewriting oxytocin's love story using CRISPR. You're listening to Technical News Reading, presented by Hakeem Alibokis Alexander on Spreaker, social podcasting, presented for World Reading Club in association with UniquilibriuM. This edition's reading focus comes to us from Biotechniques, the International Journal of Life Science Methods. It's titled Rewriting Oxytocin's Love Story Using CRISPR. It was published on January 31st, 2023. Written by Beatrice Bowlby, Assistant Editor, under the categories of Biochemistry, CRISPR, Neuroscience, News, and Veterinary Science. The neurohormone, traditionally labeled the love hormone, may have just lost that title as new research finds that prairie voles bred without oxytocin receptors show the same attachment behaviors as normal voles. Researchers from the University of California, San Francisco, UCSF, and Stanford Medicine, both California, USA, have demonstrated that oxytocin may not be as essential to the formation of attachments as previously thought. For decades, oxytocin has been described as the neurohormone essential to forming social bonds and labeled as the love hormone. However, in a study that compared mutant prairie voles lacking oxytocin receptors with control voles, the researchers found that many social behaviors were unaffected. Prairie voles are naturally social mammals, forming long-term monogamous attachments with their mating partners. Because of this, they were the original model organism for determining oxytocin's role in attachment behavior. Studies in the 1990s blocked prairie voles' oxytocin receptors pharmacologically and found that they were unable to pair bond, leading to the widespread acceptance of oxytocin as the resident love hormone. The co-senior authors of the current study, Devanand Manoli, UCSF, and Nirav Shah, Stanford Medicine, were interested in investigating oxytocin using newer genetic technologies to confirm that it is necessary for creating social attachments. They used CRISPR to genetically modify a population of prairie voles to lack oxytocin receptors and monitored their ability to form attachments compared to control voles. The mutant voles formed pair bonds with other voles just as easily as the controls. The patterns were indistinguishable, reported Manoli. The major behavior traits that were thought to be dependent on oxytocin, sexual partners huddling together and rejecting other potential partners, as well as parenting by mothers and fathers, appear to be completely intact in the absence of its receptor. Furthermore, the research found that labor and lactation, processes believed to rely on oxytocin, were mostly unaffected in the mutant voles as well. Still thought to play a role in both birth and lactation, oxytocin doesn't appear to be essential to the process, as mutant female voles could still give birth on the same time frame and produce milk, albeit in smaller quantities than normal voles. These findings indicate that oxytocin is just one part of a much bigger, more complex genetic plan. This overturns conventional wisdom about lactation and oxytocin that's existed for a much longer time than the pair bonding association, commented Shah. It's a standard in medical textbooks that the milk letdown reflex is mediated by the hormone, and here we are saying, wait a second, there's more to it than that. By investigating the formation of social bonds, Manoli and Shah hope to increase our understanding of how social bond formation is affected in psychiatric conditions, such as schizophrenia and autism. Previous work in developing therapeutics for these conditions has focused on oxytocin, but the current study highlights that it's an oversimplification to say that a single molecule is responsible for social attachment. These behaviors are too important to survival to hinge on this point of potential failure, on this single point. These behaviors are too important to survival to hinge on this single point of potential failure, suggested Manoli. There are likely other pathways or other genetic wiring to allow for that behavior. Oxytocin receptor signaling could be one part of that program, but it's not the be-all, end-all. Manoli and Shah plan to continue their investigation into the pathways and molecules associated with social attachments, with the aim of one day being able to improve the lives of those with psychiatric conditions who are struggling to form social connections. Source: Berenzin K.M., Sharma R., Mandujano M.A., and others. Oxytocin receptor is not required for social attachment in prairie voles. You've been listening to Technical News Reading, presented by Hakeem Alibokas Alexander on Wisdom, Social Podcasting, and Spreaker, Social Podcasting, presented for World Reading Club in association with UniquilibriuM. This edition's reading focus comes to us from Biotechniques, the International Journal of Life Science Methods. It was published on January 31st, 2023, written by Beatrice Bowlby, assistant editor, under the categories of biochemistry, CRISPR, neuroscience, news, and veterinary science. You can read this article and others like it for yourself by visiting biotechniques.com. That's biotechniques.com. biotechniques.com. Rewriting oxytocin's love story using CRISPR.